Hello friends, I'm here with the second video of the page replacement algorithm series, and it is first in, first out. So as I told in the previous video, I have used the same example. So this is the reference string and we have 3 frames. So what happens in FIFO? Here we are going to replace a page which is in the main memory for a long time. Right? We are going to replace the page which is in the main memory for a long time. And also I'll tell you a simple trick to do it while we are doing the example. So let's start. So now you know that the frames are empty. That means you can place the pages without any problem. So here 7, it is not in the main memory, so it's a page fault, and we are gonna place it here. And then 1, it is also not there, so it's a page fault, and 7 is already there and we are placing 1. And then 0, it is also not there and we are gonna place that. And now you can see 2, it is not in the main memory, so it is a page fault, and now we have to replace this. So this is how we do it. You can see now we are going to replace a page which is in the main memory for a long time, right? So we can count to the left, and we are going to replace the page which has the highest count, right? So here you can see 0, it is 1, and here it is 2, and 7, it is 3. That means it has the highest count, and that means it is the page which is in the main memory for a long time. So we are going to replace this 7, right? 7, and place 2 here instead of this 7, and 1 and 0 remains the same. Now 0, it is already there, so no page faults, and we write the same 2 1 0, then 3. So 3 is not here, so it's a page fault, and now we have to replace this. So now the pages are 2 1 and 0. Now you can see 2, it is only 2 times, and 0, it is 3. So the next one is obviously it is 1, right? So we are going to replace 3 with this 1. So it is 3 here, 2 and 0. And then 0, it is here, so no page faults. So the same pattern, 2, 3 and 0. Then 5. 5 is not here, so it is a page fault. And let's see what page we can replace. 2, 1, 2, 3, 4, 3, it is 2, 0, it is 1, 2, 3, 4, 5. So we are going to replace this 5. And 3, same. So here it is 2, and 2 is already in the main memory, so no page faults. 2, 3 and 5. Here also 3, it is already in the main memory, so no page faults. 2, 3 and 5. Right? Then 4. So the pages are 2, 3 and 5. 2, it is 1, 2, 3, 4, 5, 6 and 7. And 3 it is only 5 times and 5 it is only 3 times. So we are going to replace 4 with this 2. 4, 3, 5. Then 3 it is already here. Wait, before that it was a page fault because 4 was not here. And here 3 is here, so no page faults. 4, 3 and 5. And here 2 it is not here, so it's a page fault. And let's see what can we replace. 4 it is only 2 times. 3 is the highest because 5 is only 5 times. So we are going to replace 2 with this 3. It is 2, here 4 and 5. So then again 1 it is not here. So we have to replace 1 from here, 1 page from here. So what is that page? 4, 2 is only 1 time and 5. So we are going to replace this 5 with 1. And 4 and 2 remains the same. So it was a page fault. And 7 it is also not here, so it's a page fault. And let's see what page we can replace. 4 it is 1, 2, 3, 4 times, 2 it is 2 times and 1 only 1 time. So obviously it is 4. Right. So 7, 2 and 1. Then the last page 5 it is not here, so it's a page fault. And what we can replace? 7 only 1 time, 2 it is 3 times, then 1 it is 2 times. So we are going to replace 2 with this 5. So 7, 5 and 1. Right. Right. So now let's find the number of page faults. Number of page faults. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. So the miss ratio, it is 11 divided by the total pages 16, and the hit ratio becomes 1, 2, 3, 4, 5. The correct pages, number of correct pages, 5 divided by 16. Right. So this is how to do the first in first out page replacement algorithm. So what happens here is we always replace the page which is in the main memory for a long time, and also you can do it by getting the highest count to the left. So I'll write it here, highest count to the left. Keep it in your mind. So we are done with first in first out, and there is one more to go, and it is the optimal page replacement algorithm, and I will do it in the next video. So the links are given in the description, and let's meet in the next one. Thank you.